Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way.
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi. Are you sure you can prepare for product-based companies through this course?
Yes, sitting at home?
No way.
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, good evening, everyone. Can I please get a confirmation that I am properly audible and visible? So let me wait a couple more minutes for the other audiences to join. And yeah, so I would request all of you, all those who are joining right now, to kindly write your name in the chat box or just do a +1. This will help me get to know who all are watching along with me. Okay, so let me share my screen and then we can very quickly start. Okay. Presently in this current week, we are focusing upon dynamic programming, and yeah, and previously we have already done quite a lot of problems in the previous 3-4 sessions that we had. We discussed about longest common subsequence problem, substring problem, and quite other lot of problems as well. So today we will be specifically focusing upon subset sum or type of questions. Okay, so yeah, so let us start our discussion then. And just do a +1 in the chat box that I am properly audible and visible, so that I could get to so that I can just have a confirmation, and then we can start. Okay, so okay then. So first of all, let me give you a small introduction about this series. This series is called practice session for SDE interviews. And in this particular series, what we specifically do is that I pick up a particular topic every week and we go in a particular order, and then yeah, and we discuss important concepts related to those particular topics, and then we try to solve one or two problems related to them. Okay, so this is called practice session for SDE interviews. And this week we will be focusing upon dynamic programming. Next week also we will be focusing upon dynamic programming. After that we will try to focus upon graphs, and then finally we will try to complete our series with tree and linked list. Okay, so this is the plan for the remaining 4 weeks, and the series will end by the end of April. Okay, And let us see again once again. Yeah. So there is something called as complete interview preparation as well, which is also called CIP course offered by Geeks for Geeks. And if you are a student who is preparing for your interviews, what you can basically do is that refer to this particular course. This is an extremely well structured course that will help you prepare for your interviews. Okay, so you can find the link in the description of this particular streaming. Okay, so apart from that, let me give you my introduction. My name is Gaurav Kumar Shaw. You can find me on LinkedIn as well if you would like to get connected with me. And I am presently in my third year at IIT Kharagpur. Okay, so this is about me, and I'm also a mentor at Geeks for Geeks for the past 8 months or so. And yeah, so let us start with our discussion for today. Let me just check which problems are we going to solve today. Hmm. Okay, so let me just see. Yeah, meanwhile, I would request you all to kindly do a +1 in the chat box so that I could get to know your names. This will also serve as a confirmation that everything is going well and you guys are able to understand what I'm trying to teach. Okay, so okay, let us try to do the problem of target sum. Okay, so is there anyone who already know about this particular problem called the target sum? Target sum problem. Okay, so basically there are similar type of problems. All these problems come under the category of DP on subsequences. Okay, so all this problem come under the category of DP on subsequences. There is a famous problem called longest increasing subsequence called the LIS problem. If you have properly understood this problem, you can definitely apply the concept to solve other problems as well. So today we will be specifically looking into target sum. So let us first of all have a look into what exactly is a problem statement. The problem statement says that we are given an array. Okay, let me call the name of the array is ARR, and the size of the array is n. Okay, and we are also given a value called target, and our task is to build an expression from the given array where we can have place. Just a minute. Let me just. Yeah. So the basically the task is to place symbols. Okay, this is a hard category problem. The task is to place symbols positive, negative, okay, such that after you evaluate that particular expression, you will get this particular sum as the target. So basically, if our array is let's say 1, 2, 3, 1, and our target is equal to 3. So in that case, I can make something like this: 1 minus 2 plus 3 plus 1, which will account to 3 plus 4 5. 3 4 5 minus 2 is equal to 3. So our target value is also 3. So if I am able to place my symbols in this fashion, then I can get a valid target. Okay, so there is a valid arrangement of symbols. Then there are other ways also. I can also do something like this. For example, let me say that I can do something like this: plus 1 minus 2 plus 3 plus 1. Okay, so in this case also what is happening, first we have plus minus plus plus 1 2 3 and 1. mm, okay, we have to get a target of 3. So you can do something like this: you can either put a minus in the beginning of the 1. Okay, in that case this will sum to be equal, right? So you can pick up something like this: minus 1 plus 2 plus 3, and we both had plus 1. Hmm. So you put one of the minus one here, and in and next sense you put a minus. Okay, so you put a plus here. So 3 plus 2 is equal to 5. 5 minus 2 is equal to 3. Okay, so this also sums up to 3. So in fact, a negative here, a positive here, a positive here, a negative here. So there are two ways. So two ways to basically put valid symbols on places such that the sum is of the entire evaluation comes out to be equal to target. So your answer you will return is equal to 2. Okay. So now this is how you will solve this problem. So this is basically the problem statement. So first of all, we have to think that why we have to apply the concept of dynamic programming to solve this problem, because this is not an easy problem. This is a hard level problem, and yeah, let us see. Yeah. So is there anyone in the audiences who have a slight idea of how are we going to solve this question? Anyone in the audiences? Anyone in the audiences who have a slight idea of how we are going to solve this problem, how we are going to apply the concept of dynamic programming to solve this question, and why a greedy strategy will be failing? Anyone? Okay. So let me see. I see quite a few people in the audiences, but I don't see any type of interaction. So I would request you all to kindly keep the interaction going on. This will actually help me to deliver great quality content to you all. Okay. So let us look into the solution then. So there is another similar problem called need. Samir is saying need to use all possibilities. Okay, yes, basically that is the entire concept of dynamic programming. At every position, let me just give you a brief idea. So basically, let's say we got numbers here. This is a number A1, A2, A3, A4, AN. So this is the size of the array, and you will get a blank space before every number. Okay, so if the size of the array is n, you basically have n places to in which you can put the symbol. The symbol can be either plus or minus. It can be either plus or minus. So every blank space you can basically have two possibilities. So it means that you can put a two possibility here. You can also put two possibility in the next place. So basically, total number of ways is 2 to the power n, which is basically an exponential in nature, and it will be computationally very expensive. So that is the idea. We will try to apply dynamic programming because we can observe that there is an overlap in subproblems here. So what we will do basically is that we'll put a plus here and then we'll move to the next part. We can either put a minus here and then we can move to the next part. Okay. So we'll try out all possible ways, all possible ways in the form of a recursion. Okay. So this will be a recursion tree. Okay. So after that, what basically we will do here is that yeah, and then for every recursion tree that we are basically having, we will count the number of basically sub endings in which the sum is equal to the target. If the sum is equal to target, we'll just do a count plus plus, which is the basically will be our answer. Okay, how exactly we will be optimizing our solution, because this will be exponential in nature. And what are the changing variables? Yes, Samir, anyone? Yeah, I would request all of you all to kindly keep the session a bit interactive, because this will help me to basically provide great quality content to you all. Okay. भाई भाई yeah, apologies for the slight disturbance. Let us continue then. So yeah. So the solution approach that we will basically try to utilize here is that the first approach that comes to our mind is to generate all possible subsequences and try both options of placing a negative and a positive. Okay, so this is what I exactly said. And if once we are going in this fashion, and if the total sum comes out to be equal to the target value, in that case, what we will do, we will just do a answer plus plus. But this is a brute force recursion approach. So first of all, let us write a basic code that will help us understand the concept. Okay. So let us see then. Okay. Yeah, I hope I am properly audible and visible right now. Kindly excuse me for the slight disturbance from the background. So let us continue with our discussion then. So right now what we will basically do is that we will try to write a particular code that will help us understand the concept. So first of all, let me write a function called int target sum. Okay. So this function is basically accepting a value n. Yeah. So this function is basically accepting a value called int n and then int target and a vector ARR. Okay, so this is the basically the whatever values you are particularly getting. So first of all, what we have to do here is that first of all, let me find the value of total sum, which we can initially find with the help of for loop, and then we will check if the value of total sum, if the value of total sum is less than zero. In that case, we will just return zero. Okay, why we are returning zero? Because so in fact, if the value of total sum minus the target. Okay, so this is the value, right? So total sum minus target. If it is less than zero, it means that if this value is negative, if it is negative, it means that target is actually greater than the total value which you can obtain by adding all the numbers. In that case, there will be no possible answer. So you can just return zero. And if also, if the total sum, if the total sum minus target, this particular value turns out to be odd, okay, then also we will return the value as 1. Can anyone tell me why exactly this condition is there? Why if why the difference between the total sum and the target value that you are trying to get, if it turns out to be an odd number, in that case you will be returning 1. Can anyone tell me? So basically there is a similar kind of problem which is called count partition problem. Okay, so it is a prerequisite for that problem. So in that particular problem, what happens here is that, so for example, let's say you are given a problem. That particular problem is called count partition with equal differences. Okay, so count partition with a given difference, and that particular problem is something like this. In that case, what happens here is that, so basically you are given a particular array and you have to partition that particular array such that the differences are equal to k. Okay, so now what exactly we'll do here is that once we write this particular function, this will also return 0. Okay, so these are the two basically the edge cases. If the total sum minus target mod 2 equal to an odd number, in that case we will return 0. After that, what we will do basically is that we will write a variable called int s2. That particular s2 will be equal to the total sum minus target divided by 2. This is the reason we are particularly checking here, because we want to get a division by 2 sum. And after that, what we will do, we will again call a function f. This function will basically help me count the partitions. Then we will send the value n minus 1, the value s2, the value arr, and the function d. Okay, so let us now look into an implementation of how exactly this function f is being performed. And we will be applying the logic of yeah, and we will be applying the logic of this particular concept in this particular function. Okay, so let us see then. So we will be having a function called int, and this will be f. So first, this will be an index. So we are standing on a particular index. Then we also have a target in mind. Okay, and after that we also have an ARR, and we also have a DP table. Finally, what we will do here is that we will check whether index is equal to 0 or not. If index is equal to 0, then that will be a base case. So we will not we will be seeing that later. So first condition is that I am not taking that particular element. So let us say I'm not taking that particular element. In that case, what will happen? Int not taken will be equal to the count function f, and then we will have int minus 1, and then we will have target, and then we will have ARR, and then we will have DQ. Okay, because we are not taking that particular element, so the target variable is not changing. After that, what we will do basically, we will write a value called int taken is equal to 0. Okay, and again we will check that whether we can take the element. In that case, what will happen? If ARR of index, if ARR of index is equal to target, in that case, what we will do, taken is equal to, we'll write a function f, we will write int minus 1, and after that what we will do, we will subtract that particular value from the target and then call the function. Okay, so this is the important part here. Now let us write the base cases. The base case would be if index is equal to 0, if index is equal to 0, in that case we will have for certain cases. The first case will be if target is equal to 0, or and this will be and if ARR of 0 is equal to 0, whether we have successfully reached the target, or the value of the element in the first index we have particularly is equal to 0. In that case we will return 2, which means that we are able to divide this particular subset into two parts such that the sum is equal to 2, sum is equal to the given thing, right? After that, what we will do, if target is equal to 0, or the target is equal to the last element of the array, okay, in that case we will return 1, and finally we will return 0. Okay, so if you look into this problem, we have to only place negative and we have to only place positive. Now basically the problem statement boils down to this, is that we have to basically divide this entire array into two parts such that the difference is equal to the value target. So this is exactly what this problem is trying to do. We are trying to find the, if we are successfully able to divide that, in that case we will write the answer will be equal to 2 or not. Okay, so basically this is the entire concept of solving this question. So let us have a look into the coding implementation. Okay, so yeah, so those who are watching with me right now, can you please do a +1 in the chat box if you have successfully understood this question? And we also have a, course called Complete Interview Preparation. And in case if you're preparing for your interviews, you can check out that particular course, which is, it is an extremely well structured course for clearing interviews. Okay, so the name of the problem is target sum. Let me just look into it. So I'm pasting a link of the question on GFD platform so that you can access that particular question and then try to solve that question. Okay, so yeah, so let me show you to you an implementation of the problem. Let me stop sharing my whiteboard screen, and then I will be sharing my Chrome tab, that will help you, and then I will be showing you the question. Yeah, so let us have a look into it, the problem. So in this question, we are given a value ARR and a value target. Okay. So as I already said that we have to first of all find a function called f that will basically help you partition the problem. Okay, partition the given array into two parts such that you can get a difference is equal to k. If you are successfully being able to do that, in that case we can say that you can return 1, 2 or 0 based upon the condition as you can basically make. So let me just get the code ready and then paste it there. And in case if you I will be writing the exact same code which I just explained on the whiteboard, and I hope everyone is following with me like that. Okay, so you can basically return to a problem called counting the subset with given difference. That is a similar problem, and this is basically a special case of the problem. So this is a utility function of finding the partition or not. Okay, so let me put the function here. Yeah. So this is basically that f function that we just derived. And inside this particular function, what we are supposed to do, we will be doing our usual stuff. First, we will calculate the total sum, and then we will check that if the total sum is odd or not. If it is odd, in that case, we'll just return 0, because we know that it has to be an even number so as to make a particular two types of subset. Okay, so this is the value here. So let me just change the value of ARR. It is given to be A, but I have taken to be ARR, so I am writing ARR here. And the target will remain same as the target, so I suppose everything is okay. Okay, so let me just try to submit this problem and check whether it is correct or not. Okay, so there is a slight error here. We have to basically find the number of n here. So in this case, n will be the size of the array. So let me just write int n is equal to ARR dot size. Okay. So as you can see, we have successfully been able to pass all the test cases of this problem, and therefore this problem is correct. So I've already pasted the link of the problem in the chat box, and I hope you'll be able to solve that particular question. And in fact, if you need to read a particular great article about how to solve this question, you can just try to Google target sum, and you will find a GFG article as well. And okay, and there is similar problem as I just said. It is called the combination, finding the subset with a particular difference. I would request you all to kindly visit that problem as well, because these two problems are related to each other. Okay, so yeah, so now we have already reached to the end of this session. Tomorrow, once again, we will be meeting and we will try to solve a new problem, and which will be basically again related to dynamic programming. And I will try to pick up again a medium to hard level question. Okay, so we also have a course called Complete Interview Preparation. In case if you are preparing for your interviews, we would request you all to kindly visit that particular course, and because that particular course is extremely well structured and it will help you definitely in your interview preparation. Thank you very much. See you tomorrow.